Okay, so let us discuss our next heading on matrices. Let us today talk about equality of two matrices. Now, as we know, it's a very simple thing. Two matrix, let's say A, which I can represent by A, I, J, and let's say there is another matrix B, which is B, I, J, are said to be equal. So these two matrices A is small aij and B is small bij are said to be equal if there can be two conditions. Number one, they are of same size. What do I mean by size? Is the order, you can say, right? If it is a 2 cross 2 matrix, then this should also be a 2 cross 2 matrix, right? And the second condition should be that the elements in the corresponding place, the elements in the corresponding place should be same. Now this is an important thing. Once we will solve questions, we'll come to know that how GATE has asked questions on this. For example, if I say, let's say there is an example which says there is a matrix represented by W minus Z, P plus Q, P minus Q, and W plus Z is equal to, let's say, 8, 1, 3, 2, right? So this is a matrix equality. So if matrices are equal, that means this matrix, let's say A, is equal to matrix B, then first condition, are they having the same order? Yes. So they are having the same order, right? Second thing, what is the second condition which you should have? That what should happen? Yes. So second thing we are saying is that their each elements, the corresponding elements should be equal, right? So corresponding elements, if I say, what was that? Let us go back to the question. Corresponding elements, that means W minus Z, the A11 element should be equal to the, okay, so let us say what I said was W minus Z should be equal to 8. Let us say this is equation 1. What I am trying to say is that this element should be equal to this element, right? Similarly, I can say W, let us make it a bit clear so that you have no problem in understanding. W plus Z is equal to how much? 2. From where are we getting this? This element should be equal to the corresponding this element, right? So if I solve 1 and 2, now you know Linear equation how to solve it, right? Now if I solve these two equations, you'll get 2W is equals to 10, right? Or W is equals to 5. And what will be Z? Z would be how much? W is 5, Z would be, is it minus 3? Yes, right? Similarly, if you want to find out values of P and Q, what I can say? P plus Q should be equal to 1 and P minus Q should be equal to 3. solving these two, let's say we should name them equation number 3, equation number 4. So 2p is equals to 4 or p is equals to 2. Similarly, q will be equal to minus. So these are your values of p, q and w, z, right? Simple thing, but yes, questions are asked on such fundamentals, right? So now let us discuss about the next thing, that is next important thing, that is addition of matrices. Simple addition we know, but still I will give you an example. For example, if I have A 1 2 3 4 and let's say there is a matrix B which is, let's say, 5 6 7 8, and I want to find a matrix C which is nothing but A plus B, right? It is very simple. We'll have to add the corresponding elements, right? So what are the corresponding elements? If I have to add A plus B, so I'll have to add the first A11 element with B11 element. So if I say 1 plus 5, right? Second thing we'll add is, let's say, this element. This is what the element corresponding to the bth element. So it will become 3 plus 7. Similarly, this element plus this element will become the 2 plus 6 and the final 4 plus 8. So the C matrix will become how much? 6, 8, 10 and 12. Very simple, right? So we can always add this. Now if I talk about certain properties of addition in terms of matrices. Properties of addition. So the first property says that matrix addition is commutative. What do I mean by commutative? Let's say if I say the matrix A plus B is equals to X, then also I can say this X will be equal to B plus A. So if I add A plus B or if I add B plus A, it will not make a difference. You can see it by an example, very simple. If I take the same example, if I say my matrix A was 1 2 3 4 and if I say matrix B was 5 6 7 8, right? So if I do A plus B, right? So if I'm saying A plus B, I'm saying matrix A plus matrix B, correct? This will give me something like 6 8 10 and 12, which we have solved earlier. And if I say matrix B plus A, so it won't make any difference. You can see it's a very logical conclusion we can make out, right? So if I say this is 1 2 3 4, so this will become very simply 6 8 10 and 12, and you can see that these two are equal. These two are equal. So we can say that matrix addition is commutative. One marker questions sometimes are asked, properties of matrix. So you should remember these things, right? The second property of matrices is that the matrix addition is associative. What do I mean by associative? For example, if I say A plus B plus C, what do I mean by this bracket here? First I have to add A and B and then we will add C. Let's say this is equal to X. Then this will also be equal to, if I put it something like this. What do I mean by this? Here I will do B plus C first and then add to matrix A. And this will both will be equal. So this is called as associative property. Clear? Right? So this is very simple things about addition. Similarly, you can also talk about subtraction. Subtraction will also follow the same order, right? Subtraction will also follow the same thing. What do I mean by same thing? Subtraction of matrix, will it be commutative as well as associative? No. A and B, let's say, we say, let's say, you can take a note here. Subtraction of matrix or matrices is neither commutative nor associative. Seems different? Yes, we can prove it. Let us see. Example, is A minus B is equals to B minus A? No, this won't. Here, see, this is something like A plus of minus B, and this is something like of B plus of minus A. Can they be equal? No. Here you have minus B, whereas here you have B. Getting my point? So the note which we have put on is very evident, right? You can take an example, and if you still have doubts, you can take an example and you can prove it, right? The important part is the matrix multiplication, or we call it multiplication of matrices, right? Now, if I say that matrix multiplication is very simple, if I use row column multiplication, we normally use row column multiplication. What is row column multiplication? It's a very simple tool, right? We have discussed it earlier, but still I would say, let's say there is a matrix 1 2 3 4, and there is another matrix B, let's say 4 5 6 7. The general matrix I have taken. I have not taken any special matrix, but these are general matrix you can take. You can take any other value also, right? So if I want to do A into B, right? So I said we'll use row column fundamental. That means we will say this is the row and this is the column, right? This is the row we are talking about, and we'll multiply it by this column. Okay. So let us clear this out and make it legible. That was 4 and this was 6. Okay, so we are talking about this column. Okay, so first I will say I will multiply this element with this element, that is 1 into 4, plus this element with this element, that is 2 into 6. That will be the first element basically of this, right? Similarly, this row and this column, that is 1 into 5 plus 2 into 7. Here it will become what? This is this row now. So 3 into this 4. So 3 into 4 plus 4 into 6. Where from 4 into 6? This 4 and this 6, row column, right? Similarly, now this row, and we will now talk about this column. So this is 3 into 5 plus 4 into 7. So further, if you solve this, this becomes 4 plus 12, that is 16. This will become 5 plus 14, that is 19. It will become 12 plus 24, that is 36. And this is 15 plus 28, which will be 45. So this is A into B. That is row column matrix, how we multiply this, right? Now let us talk about matrix multiplications properties. This is very important thing to understand. Properties of matrix multiplication. Number one, property number one, we can say scalar multiplication of matrix distributes over the addition of matrix. What do I mean by this? Scalar multiplication. Let's say there is a scalar A. If I say it is A plus B, this can be written as K into A plus K into matrix B. So what I said was scalar multiplication of matrix to matrices distributes over the addition of matrices, right? Second property says this: if P and Q are two matrices, if P and Q are matrices, right? Then, and you can say, let's say A matrix is Aij, which is an M cross N matrix. Then P into QA will be equal to P into Q into, right? So this is very simple rules which you can always talk about, right? The third property which is important for us is that multiplication is not commutative. Very important property. What do I mean by commutative? As we have discussed this thing in when we were talking about addition of matrix. Addition, we said that A plus B should be equal to B plus A. But here, A into B, will it be equal to B cross A or B into A? No, it is not commutative. You can check it with the example which we did earlier, right? A cross B, we took an example 1, 2, 3, 4, 4, 5, 6, 7, and we multiplied those two. So if you take that example and if you solve B cross B into A, you will not get the same result, right? So that is very important. Okay. Another thing is very important, that it is, for example, if I ask you a simple question, that if A cross B exists, if A cross B or A into B exists, so is it important or is it necessary that B into A will also exist? Yes or no? Yes or no? So there is a big no. Why no? Why no? Because it is saying it's necessary. I'll give you a classic example. Let's say there's a matrix of the order, let's say 2 cross 3, and there is a matrix B which is of the order, let's say 3 cross 4. Now, is A into B possible? Yeah. We know that for multiplication, the column should match with the row, right? These should match. So, is A cross B, A into B possible? Yes, possible, right? And the resultant order will be 2 cross 4, right? But is B into A possible? B into A means you should have 3 cross 4 into, you are saying it is 2 cross 3. So now here the number of column is not equal to number of rows. So this is not possible. Clear my idea, right? So this is not commutative. We can easily conclude that matrix multiplication is not commutative, right? Now, is it associative? Second property, or what was the next property you can say? I think it was the fourth property you can say, or D property, whatever you call it, right? So is it associative? What do I mean by associative? A into B into C if I do, or if I say first I multiply A into B matrix and then I multiply it by C, this will happen? Yes, this will happen. So this is associative. matrix multiplication is associative. You can check it. I mean, you can take any example and you can also use some languaging, right? Next is, if I say that if I multiply A matrix with something like B plus C matrix, can I say something that it is A into B plus A into C? Yes, in matrix multiplication, this is possible, and this is called as distributive property, or matrix multiplication follows distributive property, right? So that is very important results which we can conclude. Questions in GATE are asked on these properties. Many times if you see the GATE papers, you will understand it very easily because these are basics. If basics are clear, then you can always get good marks in GATE examination. Okay, so let us move ahead with this particular discussion on taking a example on GATE, right? Okay, we were talking about the sixth property. Okay, let us complete that first. Let's say if I say there is a matrix A into B, matrix multiplication. If I say this is A into C, they are equal, right? They are equal. Then can I say that B is equals to C? Yes, I can say if A is a non-singular matrix. A is a non-singular matrix. What do you mean by non-singular? We'll discuss later on, right? You can say, in fact, to a nutshell, singular matrix is a matrix. Put it as a note somewhere sideaway. Singular matrix is nothing but whose determinant is equal to 0. Singular matrix is a matrix whose determinant is equal to 0, right? So that is very clear. So let us solve one GATE problem here, so you will understand things in a better sense, right? Achha, one more thing we'll discuss here before we go to the question, that is the transpose of a matrix. Transpose of a matrix. What is transpose of a matrix? We are very familiar with this word, if I am not wrong. Let's say A is 1, 2, 3, 4, right? So what will be A transpose? A transpose says that we will convert rows to columns and columns to rows, right? So that means A transpose will become, this row will convert to column. That means it is 1, 2, and this row will become the second column, that is 3, 4. So you can see that these rows have now converted to columns and the columns have converted to rows, right? So this is called as a transpose of a matrix, right? Okay, now will the order change? In this case, what is the order? 2 cross 2. What is the order here? 2 cross 2, right? So will it change? No. But this was a square matrix. Is the transpose possible in rectangular matrix? Let's say there is a matrix B. Let's say this is 2, 1, 3, 4, 1, 8. This is 2 cross 3. Is it? 2 rows and 3 columns. What will be B transpose? This will become how much? Rows will convert to column. 2, 1, 3, 4, 1, 8. So now this becomes how much? 3 cross 2. So for a rectangular matrix, yes, the order would change. But for a square matrix, it will be same, absolutely same, right? Similarly, later on we will study about A inverse. A inverse we will talk about, that is 1 upon matrix A. But the order in A inverse also, in the order of square matrix will be same as A. You can say for A inverse. For A inverse, order of square matrix will be same as A's order. Right? For example, if I say A is of the order 3 cross 3, so definitely A inverse will also be of the order of 3 cross 3. That is for sure. Okay? We will discuss it when we will discuss A inverse later on. Right? Let us take an example now from a GATE question. We will take, this is a GATE problem which appeared in 2005. Okay? So let us discuss this problem. The question was very simple. Consider matrix X which is a 4 cross 3 matrix. Consider a matrix Y, which is also 4 cross 3 matrix. And consider a matrix P, which is 2 cross 3 matrix. The question asked was, find the order of P into X transpose Y inverse, right, into P transpose and this whole transpose. The options given to you were 2 cross 2, 3 cross 3, 4 cross 3 and 3 cross. This was a gate problem which was asked. Let us make this thing a bit clearer. This was basically X transpose. This transpose should be on the right top, right? So this was a question which was asked in gate 2005, right? So let us solve this question in a nutshell. So I told you that the transpose won't change the order. Transpose won't change the order, right? So if I say the order of, we are considered only by the order. So what is the order of X transpose? Order of X transpose will be 3 cross 4. And what will be the order of Y? It is already given, 4 cross 3. So what will be the order of X transpose into Y? X transpose into Y. This is not X, but this is multiplication. Okay, so let us keep it X transpose into Y. So this will be nothing but, this is row column, right? So this will become ultimately 3 cross 3, isn't it? So can you tell me what will be the order of X transpose into Y inverse? I said inverse will have the same order. So this is 3 cross 3, right? Now if I talk about what is the order of P, P is given as 2 cross 3. What is the order of P transpose? It will be 3 cross 2. Very good, right? And P into X transpose Y inverse and into P transpose. This is what is the question given to us. So what I will say, this will become 2 cross 3 into 3 cross 3 into 3 cross 2, isn't it? This is P, 2 cross 3. This is X transpose Y inverse. This is 3 cross 3, right? And P transpose, this is 3 cross 2. So we have discussed 3 cross 2, right? So ultimately this will be cancelled out, this will be cancelled out. So ultimately the order will be how much? 2 cross 2. And the question was not this. This question was P into X transpose Y inverse P transpose and the whole transpose. So will the transpose change the order?